Welcome to another Mathnificent Conversation featuring set notation and interval notation, this time with unions. It's your nerdy math bestie Lex. Grab your pencils and let's go. Before we get started, it's that time again. It's time for our background information, which we call mint green tea. So, or statements indicate a union of two or more sets. So if you see or if you see a union, which we use a U to indicate a union, indicate a number can either be in this boundary or another. There are also and statements, which indicate an intersection, but we've already covered those in part 1. Intersection statements indicate a number must fall under all of the boundaries. So let's take a look if I have an or statement. This statement is saying I'm less than -1 or greater than or equal to 5. So less than -1 or greater than or equal to 5. The number line shows you cannot fall in both of those boundaries. You're either less than -1 or you're greater than 5. But if we look at an and statement, 0, 1, 2, this is saying greater than 0, but less than 2. And this area right here is where I satisfy both of those conditions, which is why it ends up being written 0 less than x less than 2, or x is strictly between 0 and 2, because you have to satisfy both conditions. So today we're going to focus on unions because we've already covered intersections, but you will see some intersections come back in with the unions. So let's get started. All right, we're going to start off with some set notations, rewrite them in interval notation, and see what they look like on the number line. Then we'll go through some different examples. Okay, our first example, we have x such that x is less than a or x is greater than b. So in part 1, we learned x is less than a translates to -infinity to a, or translates to union. X is greater than b means b to infinity. And the number line gives you a visual how that comes together. A, B. A and B are not included, so they get open circles. Less than or to -infinity means to the left. -infinity is here, infinity is here. And B to infinity or greater than B means goes toward infinity. So you can see if I'm talking about a number in this set, they're either in one place or the other. They're never in both. The second set is x such that x is greater than or equal to a, or x is greater than or equal to b. This means that our endpoints are now included. So they're going to get a bracket, union, bracket, b to infinity. So on our number line, a, b, -infinity, infinity. Now a is included, so we have a closed circle. B is included, so we have a closed circle. Again, you can see you can't fall in both sets. You're either in one or the other, but this time you can be A or you can be B. Our next set X such that X is strictly less than A. So this is negative infinity to A, not included, so a parenthesis. Union, X is greater than or equal to B, so B is included. It gets a bracket, and we go to positive infinity. On our number line, negative infinity, infinity, A, and B. A is going to get an open circle and travel to negative infinity. B is going to get a closed circle and travel to positive infinity. Next, X is less than or equal to A. So now negative infinity to A included with a bracket. Union, X greater than B means B is not included and travels to infinity. So on our number line, A will get a closed circle indicating it is included in the set and travel to the left. B will get an open circle indicating it's not included and travel to the right. Next, we have X such that X is less than A or X is greater than A. This is a very common one when we're dealing with domain. So this means negative infinity to A not included. So everything smaller than A, union everything bigger than A, which is the same thing as saying all real numbers except for A. So on the number line, we have A. We have an open circle at A because A is not included, but everything to the left is included and everything to the right is included. Again, indicating all real numbers except for A. Now I've thrown in a couple that sort of mix unions and intersections just so you can see how sets can be built. So X such that X is less than A, so we know that is negative infinity to A. And I have an or, so union, B is less than or equal to X and X is less than or equal to C means X is strictly between B and C, and B and C are both included. When it's time to write domains, you need to be able to mix these up. They won't all strictly be or statements or and statements, especially if you have piecewise functions or rational functions. You're going to have multiple different sets that you need to be able to put together in interval notation. So now we've got an A, a B, and a C. So I'm strictly less than A, so open circle at A and travel to the left. And I'm between B and C, both included. So B and C are in my set, and all of the numbers in between them are also in my set. Okay, our next set, X such that A is less than X and X is less than B, means X is strictly between A and B not included, or so union, X is greater than or equal to C. So that means C to infinity with C included. On our number line, A, B, C. So we are strictly between A and B. Neither of those included, so they have open circles. And bigger than C and including C. So we have a closed circle on C, and we travel to positive infinity. Okay, so this is in general how you translate between set notation, interval notation, and what that looks like on a number line. We're going to do a few examples translating, And then we're going to ask some questions about, if I give you a set, which of these numbers are actually included in that set? Okay, I've given you some sets and all the different notations, and then we're just going to fill in the chart with the two notations that haven't been filled in. First, we have x such that x is less than or equal to 0, or x is greater than 5. So less than or equal to 0 means negative infinity to 0, 0 included, or means union. Strictly greater than 5 means 5 not included and travels to infinity. So on our number line, 0, 1, 2, 3, 4, 5, 0 included and travels to the left toward negative infinity. 5 not included gets an open circle, travels to the right. So all the numbers bigger than 5, not including 5, all the numbers less than 0, but including 0. Okay, our next example, we have negative infinity to negative 2. So we know that translates to x such that x is strictly less than negative 2, or bracket negative 1 to infinity means x is greater than or equal to negative 1. On our number line, negative infinity, infinity, negative 2, negative 1. Strictly less than negative 2 means negative 2 is not included. Bigger than negative 1, but negative 1 is included. Okay, next we have a number line. We have an arrow going to the left, so we know that's negative infinity 2. We have to figure out where we stop. Halfway between 0 and 1 is 1 half, and it is not included, so it gets a parenthesis. Then we have another union that starts at 2.5 or 5/2 and travels to infinity, and that 5/2 or 2.5 is not included. This translates to x such that x is less than 1/2 or x is greater than 5/2. Next set, x such that x is less than or equal to 1.4, or x is greater than or equal to 2.8. So less than means start at negative infinity, end at 1.4. 1.4 is included. Union, because we have an or statement. Start back up at 2.8, which is included, so it gets a bracket and travels toward positive infinity. Let's draw our number line. Negative infinity, infinity. How do I want to count? Go 0, 0.7, 1.4, 2.1, 2.8. So I am less than 1.4, but including 1.4, greater than 2.8, but including 2.8. The next interval notation we have is negative infinity to 5, union 5 to infinity. Remember, in our head, we're just saying all numbers except for 5. So x such that negative infinity to 5 means x is strictly less than 5, or 5 to infinity means x is greater than 5. on our number line, negative infinity, infinity, 5. 5 is not included, but everything to the left and everything to the right is included. Okay, this next one we have a union with an intersection. So our first piece of information starts at negative infinity and travels until we get to, we got to see what these numbers are. 1, 2, 3, 4. So 2.5. And 2.5 is not included, so it'll get a parenthesis. I have a break, so that means I have a union. Starts back up at 3 with 3 included and ends at 4 with 4 not included. So everything less than 2.5 and anything between 3 and 4, including 3, but not including 4, which means x such that x is less than 2.5 or between 3 and 4. Remember, we write between 3 and 4 as 3 is less than or equal to x, x less than 4. Okay, next we have 3 things going on. X such that first x is less than negative 2. So that's negative infinity to negative 2, negative 2 not included. Union 0 is less than x less than or equal to 1.5 means x is strictly between 0 and 1.5. 1.5 included, but 0 is not. Union, x is greater than or equal to 3 means we include 3 and we travel to positive infinity. Let's go negative 2, negative 1, 0, 1, 2, 3. Okay. Negative 2 not included, but everything less than. 0 not included. Stop at 1.5, but 1.5 is included. Start back up at 3 and everything bigger. Okay, we've done some examples with translating between set notation, interval notation, and the number line. I'm going to give you some sets now, and I want you to tell me which of the numbers I give you are included in that set.
Why did the coach go back to the bank?
Why?
Because he went to get his quarterback.
Okay, given x such that x is less than 0 or x is greater than or equal to 2.6, which values of x are included in this set? Okay, let's take a look at what our set is saying. So we are less than 0, 0 not included. And the further you get in math, when you see less than 0, your brain should translate to all the negative numbers. It should just, in general, start to translate that way, just like x greater than 0 should start to translate to all the positive numbers. So now we've got all the negative numbers, union, everything bigger than 2.6, including 2.6. 0, 1, 2, 3. And start seeing less than 0 or negative infinity to 0 as all the negative numbers. And then 2.6 and bigger. Okay, I'm gonna show you where these numbers fall. So 0.5 falls here. And we can see that is not in our set. So no. 2.5 0.59 is just to the left of 2.6. Right there would be 2.59. Also, not in our set. Negative 0.00001 is right on the other side of 0. But again, I've already told you, you should start seeing this as all the negative numbers. So this is definitely in our set. And then 2.6, which are our boundary, which is included, is definitely in our set. So now you can start to see how you gauge whether or not a number is in a set or not in a set. All right, given negative infinity to 1.3, 1.3 included, union 1.5 not included to 3, 3 included, which values of x are included in this set? So let's translate. This is x such that x is less than or equal to 1.3 or between 1.5 and 3. And on our number line, we've got 1.5, 1, 1, 1.5, 2, 2.5, 3, 3.5, infinity over here, negative infinity over there. Okay, we are less than 1.3. 1.3 is about there. And between 1.5 and 3. Okay, 1.31. 1.31 is going to be on the right side of 1.3. That's not in our set. 1.5 is right here, but we know 1.5 is not included in our set. It's our endpoint that's not included. 4 is here, not included in our set. And 3 is here, which is an endpoint but is included in our set. So the only number here that's included in our set is 3. Okay, we've got a new set, x such that x is less than 2.7 or x is greater than 2.7. Remember, I discussed this just means all real numbers except 2.7. On our number line, we have a hole at 2.7. Everything to the right is included. Everything to the left is included. Okay, first thing we're checking is 0. 0 is going to fall somewhere over here, which is in our set. Pi is 3.14, is going to fall somewhere over here in our set. 2.70001 is right to the right, which is in our set. But 2.7 is not in our set. And again, remember, when you see an interval notation or a set notation like this, it means all real numbers except for the number we are excluding. We've reached our last example. Given x such that x is between -5/2 and 1/2 with -5/2 included, or x is strictly greater than 1.7, which values of x are included in this set? So this translates to -5/2, comma, 1/2 not included, union 1.7 to infinity, 1.7 not included. Get our number line going. 1, 2, 3, -1, -2, -3. -5/2 is -2.5, which is included. And 1/2 is 1/2 not included. 1.7 gonna fall about here, not included, and continue on to infinity. Okay, 1.69 is gonna be right on the left of that 1.7, not included. 2/3 is 0.6666. So that's going to fall about here. 2/3, not included in our set. -5.5 is our endpoint, and it falls here, which we know is included in our set. And 1/10 falls very, very close to 0, about right there, and that is in our set. I hope this was helpful in helping you understand set notation and interval notation. Super important when we start talking about domain and range. So make sure you understand the interval notation and the set notation so that when we get to domain and range, it flows flawlessly. Remember, you are magnificent, you are brilliant, and I will see you in the next video.